also do that using models and statistics. And when you do it with statistics, that's machine learning. And we do that to create new data, that's generative AI. And in many ways, it probably feels like this is the next evolution of humanity. This is where we're headed. And part of that is because the way we have taught these algorithms is by learning about how our own brains work. And I'll explain what that means in a second. At its core, AI is just pattern recognition. We take a big pile of data, we run it through an algorithm, we form mental models, we form a sense of what patterns exist in that data, and then we apply that model to new data that's never been seen before. So that's it, that's AI at its core. And the type of model that we use is really just dependent on what data are we using, what are we trying to do with it. So let me unpack the 4 models that are really changing the game. And I promise you there won't be any math here, but hopefully you'll understand a little more at the end of this about what's under the hood. Let's start with neural nets. And I'll give you a fun challenge. Let's say I'm an algorithm and you want to teach me what's a dog and what's a cat, just by looking from an image. Think about what are the rules that you would use to teach me a dog from a cat, right? You'd probably say, oh, pointy ears and whiskers and size and things like that. And the truth is, data scientists like me, for decades, we did that. We built thousands of rules. We say, okay, this is a dog and it's a cat. You look for these sorts of traits. And when you build an algorithm and you deploy it and it looks at new data, that model is only about 60% accurate at separating dogs from cats. Well, why is that the case? Because there are lots of big cats and small dogs. There are lots of corner cases that you can't account for. And think about, how does a child learn what a dog and a cat is? Do you give it lots and lots of rules? No, you give it lots of examples. And it learns for itself what a dog or a cat is.